everyone, Mr. Histner here, and today we are going to be looking at rhombi. So let us jump right into it. So here are our rhombis, and so what we find is that rhombi have all the same properties of parallelograms, all the ones that we've been seeing, plus we know actually that all four sides are congruent. So there's a new one. All four sides are congruent, but they're not squares. I promise they are not squares. All four sides are congruent, but they're not squares. Diagonals are perpendicular. Diagonals are perpendicular, and also diagonals make midpoints. I would say diagonals intersect. That's right, intersect at a midpoint. Diagonals intersect. Diagonals intersect at a midpoint. So let us jump into these little lads and lassies we have down here, just hanging out, being rhombi. Let's look at this one right here. Okay, this one we're told that EF 23. We're told that DF is 40. And what do we want to know? We want to know what is GF. What is GF? Well, is GF a side? Yas or nas? Yas it is. So that means it's 23. All four sides are congruent. What about HF? HF. HF looks like it's just about half. And again, it is because they diagonals intersect at a midpoint, which means that these segments on either side of that intersection point will be the same. So this is going to be a big 2-0. A big 2-0 right there. And then we want to have GH. Oh man, what could this possibly be? If only there was some way to find it out. Well, we know this one is 20. Let me just actually take this to the side. We know this one to be 20. We just wrote that down here, literally HF. We know this one to be 23, but we don't know this one. But the diagonals are perpendicular. It means that there's a right angle in here. Right triangles, no, I don't know what this one is. Do I? I don't. So this right angle in here means that we can find this. We know that 23 is the hypotenuse, so this is going to be our C. A, B, and remember we have A squared plus B squared is equal to C squared. This is the Pythagorean theorem. You know this. You've learned this before in middle school. Do not try to play me. I know that to be true. So 20 squared plus B squared is equal to C squared. Our hypotenuse is 23. The hypotenuse, let me just write this up here. Hypotenuse always across from right angle. So if I have a right triangle, the hypotenuse is here. If I have a right triangle, the hypotenuse is here. If I have a right triangle, the hypotenuse is here. It's always across from the right angle. It's always across from the right angle. It's always across from the right angle. Opposite side. Right angle. Pa-choom. And so that's how I know 23 is my hypotenuse. So 20 squared is something 400 plus B squared. 23 squared I think is 529. So what I got to do here is subtract 400 from both sides. And we have B squared is equal to 129. Again, to get rid of the square root, we need to get rid of the square. We need to square root both sides. So this is B is equal to the square root of 129, which is going to be 11.4 zers. So this one, yeah, is 11.4. And so that means this one over here is also 11.4 because these make a midpoint. So we have 11.4. And what do we want to find? We want to find GE. Well, that's going to be 11.4 doubled, right? Because it's 11.4 on the one side. It's 11.4 on the other side. One side plus the other side is the whole thing. So this is going to be a 22.8ers. Again, hopefully this Pythagorean theorem, it's not much to do. It's actually super easy to do. And once you do it a couple times, you will be golden at it, pony boy. Okay, let's look at something that has to do with angles. Well, if you know me, I'm just going to find them all, right? Because why not? So here we go. 38. 2. 38. Man, my brain is foofing. 52. What do we know about these? Oh, diagonal and perpendicular. Duh. Foofs in my brain. All right, so that means that all these are 90, right? Perpendicular, 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 perpendicular. Everyone in here is 90. Okay, so actually, easy peasy, squeeze the lemon. So we know that angle 2, for example, is going to be 90 plus 38 plus measure of angle 2. And those three are going to make a triangle. So what do we got to do here? We can find these two together, subtract that from 180, and we find the measure of angle 2 is going to be 52'sers. So 52, 52, measure of angle 7, then is going to be a 52. We have angle 4, we already found that to be 38. Angle 3, angle 3. Diagonals bisect each other. Opposite angles are congruent. Do we know that yet? I wonder why I didn't write that. This one is also diagonals bisect opposite angles. Actually, yeah, because this one is this one. Yeah, my bad. So diagonals bisect opposite angles. Yes. Okay, so that means that there's diagonals are now angle bisectors. So that means that whatever, for example, number 4 is, then number 5 is as well. So number 4 was 38, number 5 is 38. Whatever this one down here is, these are now angle bisectors. This one is 38 as well. All right, so now we need to find, oh, we already did. So 1 is 52. Oh, these are super easy. 1 is 52, and now 6 is 52. Those are alternating interior, and those are also bisected. And then finally, 8, well, we had to use 8. That's around the center, so that is 90 because the diagonals create right angles. Diagonals are perpendicular in these ones. So yes, again, the diagonals bisect opposite angles. All 4 sides are congruent. Diagonals are congruent, or diagonals are perpendicular, and they intersect at midpoints. That's what I forgot. Slipped up on that one. All right, guys, thanks for watching.